physics students. Let's take a look at how to do one of your practice problems on projectile motion. And this is the practice problem that's found on page 101 of your text. It's in practice E and it's question number 1. It says, in a scene in an action movie, a stuntman jumps from the top of one building to the top of another building 4 meters away. After a running start, he leaps at a velocity of 5.0 meters per second at an angle of 15 degrees with respect to the flat roof. Will he make it to the other roof, which is 2.5 meters shorter than the building he jumps from? Let's take a look at this in picture form first. Always makes things a little bit easier. All right, so we've got a building here that he's running across. And then we have another building over here. Okay, the distance between these buildings is 4.0 meters. And this vertical difference between the buildings is 2.5 meters. Is that correct? Yeah, 2.5. Now, the stuntman himself leaps off of this building at 5.0 meters per second at an angle of 15 degrees. Okay, because this is a projectile problem, we're going to have to use some trigonometry to find the horizontal and vertical components of this velocity that we have for him, his initial velocity. Okay, the initial velocity in my x direction, the horizontal direction, is going to be equal to the initial velocity times the cosine, because that's part of the adjacent there, of that angle. And the initial velocity in the y direction is equal to the initial velocity times the sine of theta. When we plug in these numbers and do these calculations, we get 4.82 meters per second for our horizontal component and 1.29 meters per second in our vertical component. So let's look at this first horizontally, and then we're going to look at it vertically in order to solve this problem. So, horizontally, we know that our initial velocity is equal to 4.82 meters per second. Okay, because that's that horizontal velocity, that x direction. Okay, we also know that there's no acceleration. Remember, things will keep going. We're not talking about any air resistance here. So we're not going to have any acceleration. So it's going to maintain that 4.82 meters per second horizontal the entire trip. Okay, so therefore we can use one of our simple formulas that says that the displacement is equal to the velocity times the time, because we eliminated acceleration from that equation, and we eliminated we kind of started with the 0. All right, so let's rearrange this so that we can solve for time. Well, why do we need to know the time? Well, we need to know how long he's going to be in the air, so then we can determine the distance that he's going to fall. Because if he falls too late, he's going to whack into the side of that thing. Okay, so how long is it going to take him to get across this 4-meter span with these particular parameters, this particular velocity, and this particular angle? So let's rearrange this formula. We're going to divide both sides by our velocity. Time is equal to our displacement divided by velocity. Let's just plug in those numbers now. All right, so we have said that our we're jumping 4 meters, and our initial velocity is 4.82. So let's put meters and meters per second, and these will cancel. leaving us with our seconds. And we have a time of 0.83 seconds. So that's how long it's going to take him to cross that horizontal span. But while he's moving across that way, he's also being pulled by acceleration due to gravity in a downward direction. And so let's take a look now at the vertical component of his motion. Okay, we know that his initial velocity in that y direction is 1.29 meters per second. We also know that the acceleration due to gravity is negative 9.81 meters per second squared. It's negative because it's going in the downward direction, where his velocity was jumping in the upward direction. So that's why we have a sign difference here. We know that the time is equal to 0.83 seconds. We calculated that in the last one. And with the place that he's starting from, that distance, that initial place where he's starting from, we're going to call that 0. Okay? So if you look at your formulas that you have on page 99 in your text and also on the sheet that I gave you for projectile motion, you will see that we have a formula that allows us to find y. It says that y, which is going to be our up and down direction, is equal to our initial y plus our initial velocity times time plus 1/2 our acceleration times the time squared. Now, we're calling our initial starting point 0, so we're just going to really just kind of strike that and get rid of it. We've calculated the vertical component of our initial velocity is 1.29 meters per second, and then our time is 0.83 seconds, plus 1/2 of negative 9.81 meters per second squared times our time squared, 0.83 squared. All right, when we plug in all these numbers, we end up with 1.07 meters here, minus, because we've got the negative for it falling down, 3.38 meters here, which is going to give us a negative 2.3 meters. And so he is going to be at 2.3 meters below the first building at the time that it's going to take him to cross that span. So the answer is yes, he will be able to make it across the buildings.